Hello and welcome. In this video, we're going to be solving some questions on limits at infinity. So without wasting much time, let's get right into it. Now let's take a look at this question. The question says to find the limit as x tends to infinity of 2x squared minus x plus 3 all over 3x squared plus 5. Now the very first thing to do whenever you're given a question like this is to simplify. Now when we take a look at this, for us to simplify this, 2x squared minus x plus 3, you observe that it is not factorizable. And if we substitute infinity, we're going to have 2 times infinity squared minus infinity plus 3, and that will be infinity. And this 3 times infinity squared plus 5, that will also be infinity. And I'm going to be getting something I don't want. I don't want this. Alright. So in order for us to solve this, the best way to simplify is to divide each of the terms by the highest variable, and in this case we have our highest power or variable with the highest power to be x squared. So I'm going to say the limit as x tends to infinity, and this will be 2x squared over x squared minus x over x squared plus 3 over x squared all over 3x squared over x squared plus 5 over x squared. And I'm going to have the limit as x tends to infinity of 2 x squared cancels out x squared, 2 minus, dividing this, I'm going to have 1 over x, and I'm going to have 3 over x squared all over, I'm going to have 3 x squared cancels out x squared. I'm going to have 3 plus 5 over x squared. Now the next thing to do is to substitute our infinity. So we're going to have the limit as x tends to infinity. Then we're going to have 2 minus 1 over infinity plus 3 over infinity squared all over 3 plus 5 over infinity squared. So any number over infinity is 0. So I'm going to have this as 2 minus 2 minus 0 plus 0 over 3 plus 0. And my final answer will be 2 over 3. And that is the limit as x tends to infinity for this problem. Let's take a look at another problem. It says to find the limit as x tends to infinity of 5x plus 2 over 2x cubed minus 1. So just as we solved the other question, we're just going to divide each of the terms by the variable with the highest power, which is x cubed. So we're going to have limit as x tends to infinity of 5x over x cubed plus 2 over x cubed all over 2x cubed over x cubed minus 1 over x cubed. And so we're going to have the limit as x tends to infinity. Here when we divide this, we're going to be left with 5 over x squared. X takes care of one of the x's, and we're left with 5 over x squared plus 2 over x cubed. Let me rewrite this. So we have this all over x cubed cancels out x cubed. We're left with 2 minus 1 over x cubed. And so when you substitute infinity, we're going to have limits as x tends to infinity of 5 over infinity squared plus 2 over infinity cubed all over 2 minus 1 over infinity cubed. Alright, so we're going to have this to be equal to 5 over infinity squared. Infinity squared is infinity. 5 over infinity squared is 0. And this is also 0. And this is equal to 2 minus 1 over infinity cube. Infinity cube is infinity. 1 over infinity is also 0. And so our answer is 0 over 2, which is equal to 0. And that is how we approach this question. Let's take a look at one more question. Important question. Alright, let's take a look at it. The question says to find the limit as x tends to infinity of the square root of x squared plus x minus x. Now when we substitute infinity, we're going to have the square root of infinity squared plus infinity minus infinity, which will give us infinity. And this is not the correct answer. This is not the correct answer. So we have to simplify this expression. Alright, so in order for us to simplify this expression, we're going to multiply, we're going to treat it as a fraction. So let's say this is over 1. And now we're going to multiply the numerator and the denominator by the conjugate of this expression. And this will be the square root of x squared plus x plus x all over the square root of x squared plus x plus x. And so when we multiply the numerator, we're going to have difference of two squares. So a squared, that will be the square root of x squared plus x all squared minus b squared, which is x squared. Don't forget your limit as x tends to infinity. And this will be all over the square root of x squared plus x plus x. Alright? So if we expand this, square root cancels out square. So we're left with the limit as x tends to infinity of x squared plus x minus x squared all over the square root of x squared plus x plus x. And here we have the limit as x tends to infinity. X squared cancels out x squared. X squared minus x squared is 0. So we have x all over the square root of x squared plus x plus x. Now we're going to think again, how can we simplify further? What can we do? Can we do something about this square root? Let's see what we can do about this square root. So we can say this is equal to x over, let's bring out x, right? So let's say the square root of x into x plus 1 over x squared. Yes, so we are creating a fraction because we have infinity. So we can easily, we are heading towards a point where we can easily substitute our infinity and get an answer. And so we could say this is 1 over x squared. Then we have plus x. If we expand this, we're going to have x squared plus x over x squared will give us x. So we're going to get this back. So I just rewrote this. When you have a situation like this, try to create a fraction in your denominator. Alright, so let's see what else we can do. Or let's do it this way. Let's say we have let's bring out x squared. Since we have square root, let's bring out x squared. So we're going to have something like this: x squared into 1 plus 1 over x. Yes, this is better. Since we have square roots, we can easily bring out this. Take the square root of x squared. So we have this x squared into 1 plus 1 over x plus x. Alright? So this is just, you just have to think or find your way, maneuver your way, to get something. Alright? So we have the limit as x tends to infinity of x all over. So when you take the square root of x squared, you have x root 1 plus 1 over x plus x. Alright, so now I have x common to my numerator and my denominator, so I could say this is the limit as x tends to infinity of x all over. X is common to this and to this, so x into the root of 1 plus 1 over x plus 1. Alright, when I open this bracket, I'm going to get this expression back. X times this is x times root 1 plus 1 over x, then x times 1x. So x cancels out x. Let me clear out this part. So we have the limit as x tends to infinity. X tends to infinity of 1 all over the square root of 1 plus 1 over x plus 1. Alright, so now we can easily substitute our infinity, and we're going to have the limit as x tends to infinity of 1 over the square root of 1 plus 1 over infinity plus 1. And this will be the limit as x tends to infinity 1 over the square root of 1 plus 1 over infinity is 0 plus 1. And so we have the limit as x tends to infinity 1 over square root of 1 plus 1. So let me write 1 plus 1, and this will be equal to 1 over 2. And this is our final answer. Thank you very much for watching. I've done a video on limits, introduction to limits, and I'm going to show that on your screen right now. Click on that video to understand limits if you've not really understood it, and don't forget to like, share, subscribe, and leave a comment. Thank you for watching, and goodbye.